Hi guys, I'm Mrs. M and today we are going to discuss on gas laws part 4 combined gas law. The source for this video is taken from the textbook Chemistry by Pearson Publications. Next is combined gas law. This law describes the relationship between the pressure, volume and temperature, and the one that is constant here is the mass of the gas. So in that scenario, it combines all the three laws, Boyles, Charles and Gay-Lussac's law, and it has expressed as combined gas law. Since there are three variables in this, so this equation for the combined gas law is P1 V1 by T1 is equal to P2 V2 by T2. So if you see the combined gas law, even though it is involved with having the three variables changing, you can also use this gas law for the problems that are having only two variables that are changing. For example, let's say the initial and final temperatures are same for the gas. That means T1 and T2 are same. They get cancelled. Then the combined gas law becomes Boyle's law. P1 V1 is equal to P2 V2. Let's say that the initial and final pressures are same for a gas, then P1 becomes P2, then they get cancelled out. Then the equation of the combined gas law will become Charles' law, which is V1 by T1 is equal to V2 by T2. In the same lines, if the initial and final volumes are same for a gas, then we can cancel V1 and V2. Then the equation becomes Gay-Lussac's law, that is P1 by T1 is equal to P2 by T2. So instead of having this many different laws, you can have combined gas law, and it can be useful for any type of the problem that can be used for. The best example for the combined gas law in our daily life is principles involved in the weather balloons. We all know that weather balloons are used to gather data about Earth's atmosphere. This follows the combined gas law. As the balloon rises, both temperature and pressure outside drops. So these changes will have opposite effect on the volume of this balloon. Let's say the temperature is decreased, then volume also decreases. But when the pressure is decreased, then volume increases. After going to some distance, if the weather balloon got burst, then we can infer that the drop of pressure affected the volume of the balloon rather than the drop of the temperature. So let's solve a sample problem on combined gas law. A gas at 155 kilopascal and 25 degrees Celsius has an initial volume of 1 liter. The pressure of the gas increases to 605 kilopascal as the temperature is raised to 125 degrees Celsius. Then what is the new volume? Step 1, you have to figure it out what's the known data and unknown data. So if you see P1, P2, T1, T2, V1 are given. T1 and T2, since they are in Celsius, we need to convert into Kelvin scale. So plus 273 you need to add. Then the unknown is V2. So step 2 is what kind of gas law we should be applying. Since all the three variables are changing, so you can use the combined gas law. Then the step 3 is we have to rearrange the formula to find unknown variable V2. Since P2 and T2 are along with V2, so to cancel that P2, T2, we have to multiply both sides with T2 by P2. So then the formula becomes V2 is equal to P1 V1 T2 by T1 P2. So last step is plug in the known data to solve V2. then we do get 0.34 liters. Okay guys, time for the checkpoint. Read the problem and try to solve using the combined gas law.